Welcome to our exploration of model evaluation in machine learning. In this journey, we will uncover why evaluating models is a cornerstone of successful machine learning projects. Machine learning is transforming our world, powering everything from self-driving cars to personalized recommendations. These advancements are possible because of the rigorous evaluation processes that ensure models perform as expected in real-world scenarios. But building a model is only half the battle. The true challenge lies in evaluating its performance accurately and thoroughly. Evaluating its performance effectively is just as critical. This involves using various metrics and techniques to measure how well the model performs on unseen data. Model evaluation helps us understand how well our algorithms generalize to unseen data. It provides insights into the model's strengths and weaknesses, guiding us in making necessary adjustments. It allows us to compare different models and choose the best one for our specific task. By comparing models, we can identify which algorithm performs best under certain conditions and constraints. By rigorously assessing our models, we can identify weaknesses, improve performance, and ensure reliable and robust results. This continuous process of evaluation and refinement is what drives innovation and excellence in machine learning, ultimately leading to more accurate and dependable outcomes in various applications. In this section, we delve into supervised learning, which encompasses tasks like classification and regression. Supervised learning is a cornerstone of machine learning, where the model is trained on a labeled dataset. This means that each training example is paired with an output label, allowing the model to learn the relationship between inputs and outputs. The ultimate goal is to make accurate predictions on new, unseen data, and relies heavily on labeled data for training. The quality and quantity of this labeled data significantly impact the model's performance. High-quality labeled data ensures that the model can learn effectively, while a large quantity of data helps the model generalize better to new examples. In classification, our goal is to predict the correct class label for a given input. This could involve distinguishing between different categories, such as identifying whether an email is spam or not, or classifying images of animals into species. The model's ability to correctly classify these inputs is crucial for its practical application. Accuracy, the ratio of correct predictions to the total number of predictions, serves as a fundamental metric. It provides a straightforward measure of how often the model's predictions are correct. However, accuracy alone may not always be sufficient, especially in cases where the data is imbalanced. For example, in a dataset where 95% of emails are not spam, a model that always predicts not spam would have high accuracy but would be ineffective. For instance, an email spam filter's accuracy reflects its effectiveness in distinguishing spam from legitimate emails. A high accuracy rate means the filter is reliable, but other metrics like precision and recall are also important to consider. Precision measures the proportion of true positive predictions among all positive predictions, while recall measures the proportion of true positive predictions among all actual positives. In regression, where we predict continuous values, metrics like mean squared error, MSE, and R-squared come into play. Regression tasks might include predicting house prices based on features like location, size, and age, or forecasting stock prices based on historical data. MSE quantifies the average squared difference between predicted and actual values, providing a measure of the model's prediction error. A lower MSE indicates a model that makes predictions closer to the actual values, which is desirable in most cases. While R-squared, ranging from 0 to 1, indicates how well the model explains variations in the target variable. An R-squared value closer to 1 suggests that the model explains a large portion of the variance in the target variable, making it a useful metric for assessing the model's explanatory power. Together, these metrics help us evaluate and improve the performance of our predictive models. Now, let's go beyond accuracy to consider precision, recall, and the F1 score, especially in contexts like fraud detection. These metrics are crucial for understanding the performance of a model in a more nuanced way. While accuracy provides a general overview, it can be misleading, especially with imbalanced data sets. In such cases, accuracy might give a false sense of security, making it seem like the model is performing well when it might not be. Consider a fraud detection system. Achieving high accuracy might be easy if only a tiny fraction of transactions are fraudulent. For instance, if 99% of transactions are legitimate, A model that always predicts legitimate will have 99% accuracy, but will fail to detect any fraud. However, we need to consider false positives, legitimate transactions flagged as fraud, and false negatives, fraudulent transactions missed. False positives can lead to customer dissatisfaction and loss of trust, while false negatives can result in financial losses. Precision measures the accuracy of positive predictions, reflecting the system's reliability in flagging fraud. High precision means that when the system flags a transaction as fraudulent, it is likely to be correct. Recall, on the other hand, quantifies the model's ability to identify all actual fraud cases. High recall means the system is good at catching most of the fraudulent transactions, even if it sometimes flags legitimate ones incorrectly. The F1 score, the harmonic mean of precision and recall, provides a balanced measure, especially when dealing with imbalanced data sets. It helps to ensure that neither precision nor recall is being neglected, offering a more comprehensive view of the model's performance. Data scientists often rely on these metrics to fine-tune their models. By balancing precision and recall, they can create more effective and reliable systems. Visualizing these metrics through charts can also help in understanding the trade-offs and making informed decisions about model adjustments. In team meetings, discussing these metrics can lead to better strategies for improving model performance and addressing any weaknesses. Ultimately, a well-balanced model using precision, recall, and the F1 score can lead to a successful fraud detection system, ensuring happy customers and secure transactions. Lastly, let's explore the Jacquard Index, also known as the intersection over union, which finds applications in tasks like object detection and image segmentation. It measures the similarity between two sets by calculating the ratio of the size of their intersection to the size of their union. For example, in object detection, we can evaluate the overlap between the predicted bounding box and the ground truth bounding box of an object. A higher Jacquard index indicates better alignment and a more accurate detection. Unsupervised learning, navigating the world of unlabeled data. Unsupervised learning focuses on unlabeled data, aiming to uncover hidden patterns and structures. A common task in unsupervised learning is clustering, which groups similar data points together. To evaluate how effective these clustering models are, we often use metrics like the silhouette coefficient. The silhouette coefficient quantifying cluster, cohesion and separation. The silhouette coefficient is a measure that tells us how well each data point fits into its assigned cluster in comparison to other clusters. Its values range from -1 to 1. A high silhouette coefficient suggests that the data point is well clustered. Conversely, a value close to 0 indicates ambiguity in cluster assignment, and negative values may signal that the data point could be better suited to a different cluster. Reinforcement learning, maximizing rewards in dynamic environments. Reinforcement learning involves an agent learning to make decisions in an environment to maximize cumulative rewards. Unlike supervised learning, where feedback is immediate, reinforcement learning often involves delayed rewards. Evaluating reinforcement learning models typically involves tracking the agent's performance over time, measuring metrics like the total reward accumulated, the number of steps taken to achieve a goal, or the average reward per episode. The power of visualization confusion, matrices and beyond. Visualizations play a crucial role in understanding model performance. Confusion matrices, for example, provide a clear representation of classification results, showing the counts of true positives, true negatives, false positives, and false negatives. This allows us to quickly identify areas where the model excels or struggles. Other visualizations, like ROC curves and precision recall curves, offer insights into the trade-offs between different evaluation metrics. By visualizing model performance, we gain a deeper understanding of its strengths and weaknesses. Choosing the right metric, a contextual decision. Selecting the right evaluation metric is crucial, but depends heavily on the specific application and data. For instance, in medical diagnosis, where false negatives can have severe consequences, recall might be prioritized over precision. In marketing campaigns where maximizing true positives while minimizing costs is key, precision might take precedence. Understanding the business problem, the consequences of different error types, and the data characteristics is vital for choosing the most appropriate metric. Conclusion: the never-ending quest for model improvement. Evaluating machine learning models is not a one-time task, but an ongoing process. As we gather more data, encounter new challenges, and refine our objectives, we need to continuously assess and improve our models. By embracing a data-driven approach, leveraging appropriate evaluation metrics and visualization tools, and fostering a mindset of continuous learning, we can unlock the true potential of machine learning and build robust and impactful applications. Thanks for watching and subscribe to Vlab Solutions.